Hello students. Now you all know that the most important function of the blood is to supply oxygen to each and every cell of the body and take away the carbon dioxide and throw out of the body. So what who does the function in the blood? It is RBCs, red blood corpuscles. Now they are also known as erythrocytes, but they are known as red blood corpuscles because they are red in color. They give the blood that red color because they have hemoglobin. Hemoglobin is a compound which is made up of heme, iron, and a protein globin, which has affinity towards oxygen. They readily combine with oxygen and they readily give to the cell when required. So that is the property of hemoglobin. So let's see. Hemoglobin is a respiratory pigment and it is made up of heme and globin, iron and protein. Now this combines with oxygen forming HbO2 oxyhaemoglobin. So this oxyhaemoglobin travels and it gives to each and every needy cell. Then it also combines with carbon dioxide because it has to bring carbon dioxide to the lungs to be thrown out of the body. So it combines with carbon dioxide. It forms carbaminohaemoglobin. It forms a compound which is carbaminohaemoglobin. Now, it has got affinity towards carbon dioxide, but more than carbon dioxide, it is carbon monoxide that it gets attracted to. So it forms a compound which is carboxyhemoglobin. Carboxyhemoglobin. So carbon monoxide, where do we find? In wherever the wood is burned or pollution is produced by the vehicle, you find production of carbon monoxide. So it is very dangerous to sleep near a furnace in a closed room. It happens in the cold region. So if the room is closed, carbon dioxide will combine with hemoglobin and it will lead to death. So this is what happens with the carbon monoxide. So be careful. Now, these RBCs are designed to hold more of oxygen. So here you can see this is the structure of RBCs. This is the structure of RBCs. They are very minute and they are biconcave. Now, concave, that means it has to be like this. Biconcave, they are concave from both the sides. That increases the area for holding oxygen. So they are biconcave. Minute biconcave disc-like structure. So it is disc-like structure and it is flat in it is flat in between, in the center, and in the periphery it is rounded. So flat in center, thick and rounded at the periphery. Now its diameter is 7 micron. How much is 1 micron? If you take 1 mm and divide into 1000 parts, then 1 part is 1 micron. So here the diameter of RBCs is 7 micron and it is represented by this symbol mu. Now, number of RBCs per cubic mm of blood. In lab, you are going to take the blood on the slide and there are markings on it. So, in this part where it is per cubic mm, how many RBCs you find? So, it is different for male and female. In male, it is 5 million. Whereas in female it is 4.5 million per cubic mm. Now in children it is more. It is around 6 to 7 million per cubic mm. Now, the amount of RBCs vary. When we are sleeping, it reduces by 5%. If we are very active, it gets increased by 30%. Or during pregnancy or during some emotional outburst, the RBCs they increase. And people living at a height of more than 4,200 meters, then their RBCs also increases by 30%. Now, they have concavities. It is actually a spongy structure which has got hemoglobin. So here the structure is colorless. It is colored only because of hemoglobin. Now this concavities, it is concave on both the side, that increases more of oxygen. Absorption of oxygen takes place and it travels through the cavities. Now, they will be traveling through the capillaries in a file in one line. So they have to be very minute structure so they can move in capillaries also. Capillaries are the minute vessels. If you see your buccal cavity, you will see the capillaries here. The supply of blood takes place to each and every region. So that is what the capillaries do, and they should be able to travel through the capillaries. So that is why they are very small. So they are very adapted. They are very adapted for carrying out the oxygen to each and every cell. Now, if you see their life and death, where they are produced. Now, they do not remain for throughout life. You don't have the same RBCs. They get destructed. They have the lifespan of 120 days. They'll remain only for 120 days and then they will be destructed. So first let us see where they are made. They are made in bone marrow of long bones, that is ribs, breastbone and the ileum. The ribs, the breastbone and the ileums, there is space in between the big bones. That space is known as bone marrow. The synthesis of RBCs takes place in the bone marrow. Which bone? That is ribs, breast and ileum in the adult. Ileum of the hip girdle, that is the pelvic girdle. Now, in adult, in embryo, that is when the formation of that baby is taking place in the mother embryonic stage. Embryo, it is liver and spleen. Liver, spleen produces RBCs when they are in embryonic form. Now in children up till 5 years, all the bones, all the bone marrow throughout the body produces RBCs. It is later on in adult, only specific bone produces RBCs. Now, nuclei is not present. It's an adaptation. They give up the nuclei. There's more space for oxygen combining with hemoglobin. So, initially when it is produced, nuclei is present. Later on, it gives up nucleus and it becomes enucleated. It becomes enucleated. Now, the destruction, where the destruction of RBCs takes place, it is in spleen, liver and bone marrow. Here, the destruction takes place. And then in the liver, it forms bilirubin, the pigment. Now, they are destroyed 2 million per second. So much is the rate. Now, the RBCs are destroyed every second. So, it becomes 1% every day. That is 2 million per second they are getting destroyed. So, it becomes 1% of the total RBCs gets destroyed every day. Now, adaptation, nucleus, it gives up nucleus, so more space should be there for hemoglobin to carry oxygen. Now, it gives up mitochondria also. These are the cell organelles. All the cells, they have these organelles, but RBCs, they are specially designed, enucleated. No nucleus is present, no mitochondria is present, because if mitochondria is present, the oxygen will get oxidized here. Energy will be produced, but they need not produce energy. They have to carry the oxygen to the cell for production of energy. So they give up mitochondria. Then endoplasmic reticulum is also absent here, so that it can move freely through the capillaries, that they become minute, are able to move through the capillaries. So all these organelles, nucleus, mitochondria, endoplasmic reticulum, they give up, for it's an adaptation. So it's disc like, and here initially they having nucleus, they are bulging here, but when they give up the nucleus, then they become flattened in between. So the base, if disc like, here they are flattened, here sides they are bulging a little. So this is an adaptation of the RBCs. Now, sometimes due to some reason, the multiplication of RBCs will be very high, which is not good for our health. So that is known as polycythemia. Poly means many. Polycythemia is a disease where the RBCs will increase. So what the doctors will do? Remove some of the blood so that the RBCs level will come down. Now, when there is less of RBCs, it is known as erythropenia. When the RBCs are less, it is derived from the name of this RBCs, which is known as erythrocytes. The cells are known as erythrocytes, the other name of RBCs. So all this structure, adaptation, function leads to the function of the blood of carrying oxygen to each and every cell for oxidation and release of energy.